So in the package here a few videos back, there was a couple of these Luyuan boxes I'd ordered with my cells, and in this video I'm going to show how I put mine together. Maybe it'll give a few ideas. Like I say, we always trade ideas on the do-it-yourself solar forum, so hope you enjoy it and pick up a few pointers, and any comments below, feel free to share them. Alright, let's get started. So I started putting these boxes together here, and I was putting the front panel all together and stuff like that first, and don't do that. Take the top cover off if you order it with wheels, and get the stuff all out of the box, flip it over, put your wheels on right away. I just set it here on a barrel, and I got a piece of the packaging foam there underneath it, so I'll get these wheels on and then I'll show you what I'm doing next. So one of the problems I run into here is these. I told her I was using a JK BMS. I sourced the BMS myself, and I was using a 200 amp one, and she sent them with a 200 amp breaker. One problem is, though, she sent a 200 amp breaker in the box, but whoever made the hole here, it ain't big enough. So I ended up, I'm going to have to, as you can see, it's a little bit longer. So I got to take both these covers, and I got to cut that open and file it all down and make it fit. So make sure all your stuff fits, like your screen, the blocks she gave you, you know, make sure everything fits before you start putting anything together in case you got to modify something. So I test fit the cells in here, and they're a little loose. So I'm adding a piece of Poron on each end, 3 or 4 millimeter. Got my separator plates on the side, and then I'll put a separator plate here, right here, and then start putting my cells in here. Same thing on the other end. I got just a sheet of Poron on there, and that'll give me a little compression and keep the cells from moving around. So I got all the cells in with a separator plate in between each one, Poron on the end here, and I got my screws just started in these holes. You can't have a BMS or nothing on this because you got to get these 3 center ones in here. Okay. Next, we're going to start putting the bus bars in. You want to do that before you tighten any of this down. You want to get them just so they get your cells all aligned. In case you're wondering how these are made, I got one end in the vise here, but see, they laminate those with thin sheets. Then they must electrostatically weld the ends. So pretty neat how they made it. Makes it flexible. It's solid here on the end. So I got all the bus bars on here. Before I put them on here, I clean all the terminals. You can use rubbing alcohol, or I just use a can of carb cleaner. The reason you want to put these all on before you torque the other end down is this end here, these 2 cells have to be slid in pretty tight to make this bus bar. It's not much play there. The other thing is you have 4 holes here, you got to get everything lined up. So I've got the end here torqued down, and then I'm going to start torquing down cells. I'll leave one bolt loose because I got to run my balance leads, but anyway, we're moving along. Next I'll be putting on BMS. So one problem I've noticed here with these bus bars is, and you can probably readily see it, I got it propped up here with a bottle of water, but see that there, that heat shrink is too long. What happens is when you lay it on top of this terminal, it's going to create an air gap in there. We want as much contact area in between the bus bar and the flat surface of the terminal as we can get. So you have to take a utility knife and trim these back so that they clear that battery terminal. All right. So here I've got one that's been trimmed up. You want to cut it past where that curve is there, and you can see in comparison to the one that wasn't trimmed. So get out the utility knife, get them trimmed up. You don't need to cut the top off, just slit it on the sides and get that bottom chunk off there, so that way it sits flat on your terminal. So on the copper bus bar that goes on the end here between the 2 banks, get yourself out a piece of real fine sandpaper or a Scotch-Brite pad and clean the underside up there where the mating surface is going to be. And then clean it with some cleaner. I like to use carburetor cleaner. Alcohol will work too, whatever you want. Just make sure it's clean. Get yourself some nail locks. Put a real light thin coating on it, because you're joining bare copper with aluminum, and that'll help prevent any corrosion problems down the road. So I got them all trimmed and put on there, and as you can see, there ain't no heat shrink going to be sandwiched in between the battery terminal and the bus bar. Now, On every positive that's going to get a balanced lead here, I've left those screws loose, so the rest of them are all snugged down and ready to go. So we're going to get the BMS on and then start running balance leads. Let's show you my BMS plate here. So this is the BMS I want. It wasn't important to me that it had inverter communication. I really don't care. And I did want a Class T fuse in here. So basically I've already ran my cables. I got them ready to go. And from this terminal it'll go over to the breaker. On this side I just put post on here, and I've got my negative leads going to there. If you look underneath here, I use a standoff. I think there were 3mm bolts or holes in the BMS in the back side. I've seen guys use a zip tie with Velcro to hold it on there and this and that. But anyway, the issue you run into here is when you make this plate, and I knew what I wanted, so I mean, I'm going to do what I want. So these screws here get tight on each end, and that's because of the 4 posts that are sticking there, and that's just the way it is, you know. If she'd have made that a little different, yeah, it'd have been a lot easier. As far as the guys using the JK with the inverter communication, I don't know how she's putting the post on those, but I told her what I had, and they sent just a piece of this separator material to them 4 posts, and ain't no way I was going to use that, and it wasn't big enough anyway to get a Class T on there and everything I wanted. So as far as your leads on these here, these are 7-gauge wire, and what I used is a 6-gauge terminal, but I own a Temco crimper, hydraulic crimper, and I used the 6+ die on it, and that worked really well. Of course, heat shrink on everything. For the negative cable, it's just 2 gauge. This is going to be a 200 amp BMS, and that's 105C. That's from Windy Nation. That'll handle 215 amps or something like that. On the top one, she supplies you with a terminal here, and I put them both together and crimped them down using the Temco again. Worked my way down from like, what was it? Probably a 1 gauge or 2 gauge, and then down to 1 gauge, and just kept dropping until I got down to about a number 4, which should be about right if you're going to crimp 2 number 7s together. So heat shrink that. You know, I thought about putting 2 separate terminals, but this worked out pretty good. I'm not complaining. I'll show you what I did on the breaker when we get to that later. But yeah, basically I made myself a template to make this plate, and being I had a couple of them to do, that's the way I did it. This is a 200 amp BMS, but I only have a 175 amp Class T fuse in it, and I'm not worried because I'm going to have 5 batteries on the bank here, and I'll be lucky at peak if I'm drawing, you know, 30 amps per battery or 40 amps per battery. So, you know, that's not going to be an issue here. Now, you guys that are running marginal banks and a lot smaller, yeah, you know, it's, as you say, if you run it hard and hot, it'll have a failure point at some point. The other wire is just a 2 gauge again. Temco ends, you know, nothing special there. So I'll get this in here, and then we'll work on the rest. So I got some of these nice little Arrowhead zip ties. They work really good in these holes here, so I'm just tidying up my wires and run them. I usually set my channels in here, and I have it in the slot, and eventually it'll go over here, but I just put it in there to hold it. So I ran my wires all the way down, and I run them out in what slot I want. That way I keep them all in order. I do cut my wires off. Some guys don't, but, you know, I prefer. But I always use the farthest screw away. That way, if I ever had to put a new end on it, I could just move it back to this screw, and I'd have enough wire if I had to put a new end on it. So I'm going to start getting these all tied up and put some ends on them, and I'll be back. So it's a little while later. Got these all ran and tied up nicely, and as you can see, I don't hook up my ground wire here until I've voltage checked. So I'm going to plug here and voltage check each wire. If you notice down on this end, I ran the wire this way. You can run it on either end of the bus bar. It ain't gonna make any difference on the reading. I ran it that way because that way if I ever have to take it apart, I know the long lead where it goes to. The reason I had to run that lead down this side is because of the way my BMS is mounted. Your wire ain't gonna be long enough going to the other side. So I just ran it down through this one and then just crossed. Like I said, you can put it on either end. It ain't gonna make any difference. So I'm going to get my voltage check all done here, and then I'll get my negative lead hooked up here and start getting all my other stuff plugged in here and get ready to put my faceplate on. So I did my voltage check. I just hooked my negative lead here to negative on this battery and got my multimeter here, and then I'm going to probe every one of these. And it should increase by about 3.2 volts every time on every wire. So later. Voltage checked out good, so I got the negative hooked up, put my covers on, got them all numbered. In case anybody's wondering what I use for crimpers and that, I got a snap-on one like this with long handles. I mean, this thing is the bomb. I've had it forever. Actually own several of them. Then I bought a nice Klein automatic stripper for this small wire. I use it all the time on small wire. Larger wire, I'll just use a GB pliers, you know, stainless one. But this thing for small wire can't be beat, you know. I really like that. So I don't heat shrink my terminals. I did on my house one, but on these I decided I wasn't gonna. Yeah, you know, it's a mixed bag, but usually if you start seeing problems on cell voltage, you're gonna start looking anyway. And like I say, I want to be able to see if I got corrosion there rather than screw around and cut the heat shrink off and this and that. I do have a printer for printing heat shrink tubing, and I could have slipped on like I did in my house, and I'll show that someday in a video. But for this one, nah, I just said I'm doing it simple, easy way, the way most people would do it. So anyway, I'm going to get my faceplate on here and keep moving on. So on the breaker here, on the cables, they supply that copper ferrule there, and I tried about every trick I could. Leave a little insulation on the end there and then try and slide it on. I tried the zip tie method, still couldn't get it on. Finally gave up and went over and got my assortment here that I got off Amazon here a couple years ago. And these are real copper, and they're tin plated. They're really nice, but they're tapered on the end, so you can get that fine stranded wire in there. The only way you're going to get that copper one on there is if you're either leaving some strands hanging out or you're cutting them off. But then I just used my Temco battery cable crimper with a 4-gauge die in it and just crimped it on there, and they fit. There's hex then, and they fit into the terminal on the breaker really well. I did pull on them hard, and they're holding. So one thing I tell you is, don't waste your time putting this bracket on until you got your cables in here, because the screw to tighten it's on that side. You're only going to get it to it with the breaker off. So the rest of the front panel I do have together. I got my switch on there, and she's ready to go. I had to bore this one out to fit my bus bar. I had to bore it out to 3/8, just use a step drill. So other than that, this is all ready to go, and we'll get on to the next step. So I got the cables bolted on here. My CAN cables here attached. I used the plastic strap and self-tapping screw to hold it on in there. I'm holding the front cover up here with just some extra balance laying on. There's a couple pegs down there in the bottom that'll hold the bottom. So thermistors are all fastened down. I just used some refrigeration insulating tape to hold them down. As far as my cover here for my Class T, I just take a hole saw and put a hole in it and then saw the rest out, make a nice notch in it, and next time you see this, the cover will be all bolted on. Yeah, it's a little tight in there, but it ain't too bad. Everything's hooked up. I got everything else there done. Screen works like it's supposed to, and nothing blew up, so I guess it's another successful battery build. So I'll get this all charged up and be moving on, and hope you enjoyed this video. Until next time, thanks for watching. Catch some rays, and we'll see you later.